Good morning. Today our new class is biased positive clippers and biased negative clippers. Today our new topic is biased positive clippers and biased negative clippers. Okay. And next, recap of this presentation. In previous class we discussed about unbiased series diode positive clipper and unbiased series diode negative clipper and unbiased shunt diode positive clipper and unbiased shunt diode negative clipper. So, what about topics? Unbiased series diode positive clipper, unbiased shunt diode positive clipper and unbiased series diode negative clipper, unbiased shunt diode negative clipper. These topics are completed in previous class. Okay. And next, objectives of this presentation: on completion of this period you would be able to understand biased series diode positive clipper and biased shunt diode positive clipper and biased series diode negative clipper and biased shunt diode negative clipper and summary. These topics one by one discussing now today class. Okay. So here observe this. So biased positive clippers are divided in two categories. So that is biased series diode positive clipper and biased shunt diode positive clipper. And similarly, biased negative clippers are also divided in two categories: biased series diode negative clipper, biased shunt diode negative clipper. Okay, one by one discussing now. First of all, the first topic is biased positive clippers. Biased positive clippers, in this case, so there are two types: biased series diode positive clipper, biased shunt diode positive clipper. Okay. So these two topics we discussed in first topic, biased series diode positive clipper. So observe this. This is the figure of biased series diode circuit diagram and input and output waveforms. Observe these waveforms. Input waveform. Input is x-axis is taking on time in milliseconds, y-axis is taking on voltage. So here input voltage is nothing but Vi and output voltage is nothing but V0. Okay. So VR is the resistive voltage. Okay. Next. So this is the construction of circuit diagram. So this diagram consists of one diode, one resistor and one battery. So VR is the bias battery. Okay. So first of all, input is applied to the diode. Next, when the diode is connected in series with the input and output, so with the VR as bias is called biased series diode positive clipper. Okay. So this is the figure of biased series diode positive clipper. I repeat this point again. When the diode is connected in series with the input and output with the VR as bias is called biased series diode positive clipper. So this is the figure. See this figure. During positive half cycle of input signal. Here there are two voltages. One is input voltage and other one is bias voltage. One is input voltage and other one is bias voltage. Then compare these two voltages. First of all, if input voltage is high, then what about the output? And second case, if bias voltage is high, then what about the output voltage? Observe one by one. Okay. During positive half cycle of the input signal. So input signal we can apply complete full cycle. You cannot apply complete full cycle at a time. So just we can apply. So one time is positive half cycle and another time is negative half cycle. Okay, first of all we can take the positive half cycle of input signal. During positive half cycle of the input signal, so there are two conditions. One is for Vi or V1 is less than VR. So V1 is less than VR. In this case, which voltage is high or which voltage is low? No, bias voltage is high. Therefore, the diode is forward biased because its anode is at a higher potential than its cathode. So it conducts and acts as short circuit. Why its anode is higher potential than its cathode? Because so cathode is connected to input voltage and anode is connected to bias positive terminal. Okay, so if for condition Vi or V1 is less than Vr, in this condition bias voltage is high, so compared to input voltage. That's why diode is forward biased, because its anode is at higher potential than its cathode. So diode is forward biased, it conducts currents and it acts as a short circuit. Hence the output is same as the input voltage. Then input is first of all we can apply the input that goes to the output. Okay, hence the output is same as the input voltage, that is so VO2, that is VO2 the drop across the resistor R and VR. Okay, so next for the condition so input voltage or V1 or Vi is greater than Vr. In this case input is high compared to bias voltage, then the diode is reverse biased because its cathode is at a higher potential than its anode. So it is reverse bias, it does not conduct and it acts as a open circuit. So that means open circuit means there is no current flows through the resistor. So there is no voltage drop across the resistor. So the output voltage V0 is equal bias voltage VR. Therefore the output voltage V0 is equal bias voltage VR. That is the input signal above VR. That is the input signal above VR is clipped off. For V1 is greater than VR. V1 is greater than VR. So okay, observe these waveforms. The during positive half cycle, so the output voltage is equal bias voltage. Okay, after biasing voltage they clip off the waveform. Okay, so therefore the two conditions V0 is equal Vi, output voltage is equal input voltage for Vi is less than VR condition. So then V0 is equal VR for Vi is greater than VR. Okay, so again you can apply negative half cycle of the input signal. During negative half cycle of the input signal, the diode conducts and hence output voltage is same as the input voltage. Diode conducts means it is in forward bias. Then there is current flows through the circuit, that's why output is same as input. Therefore V0 is equal Vi or V1. So observe this waveform in negative half cycle. So complete negative half cycle appears at the output side. Okay, so this is the biased series diode positive clipper. And the second topic is biased shunt diode positive clipper. Biased shunt diode positive clipper. See this figure and input and output waveforms of biased shunt diode positive clipper. This is the figure shows the circuit of shunt diode biased positive clipper. So this figure observe during positive half cycle. During positive half cycle of the input signal. During positive half cycle of the input signal, the diode conducts as long as the input signal is greater than bias signal voltage is greater than bias voltage. Okay, so that means the condition Vi is greater than Vr. In this case input is high. The diode conducts means so then output remains at Vr until input voltage becomes less than Vr. I repeat this point again. So during positive half cycle of the input signal, the diode conducts as long as the input voltage is greater than bias voltage plus Vr, and the output voltage remains it. Diode conducts means it is forward bias, because observe this diode in this circuit. So cathode is connected to, observe this diode. The diode conducts as long as the input voltage is greater than plus Vr. So we can depend on condition only in this case. The diode conducts as long as the input voltage is greater than plus Vr and output remains at plus Vr until the input voltage becomes less than plus Vr. When the input voltage is, next, when the input voltage is less than plus VR, when the input voltage is less than plus VR, the diode does not conduct and it acts as a open switch, hence output voltage is same as the input voltage. Okay, output voltage is same as the input voltage. Therefore, the output voltage V0 is equal Vi. Therefore, the output voltage V0 is equal Vi if Vi is less than or equal plus VR. So, next condition is V0 is equal VR if Vi is greater than plus VR. Okay, so observe this positive half cycle. So only, so up to VR waveform is appeared, after VR waveform is clipped off. Okay, and next, during negative half cycle of the input signal, during negative half cycle of the input signal, the diode does not conduct, the diode does not conduct, and hence output voltage is same as the input voltage, that is V0 is equal Vi. I repeat once again this point again. So during positive half cycle of the input signal, during positive half cycle of the input signal, the diode conducts as long as the input voltage is greater than VR and output remains plus VR until input voltage becomes less than plus VR. Okay, so observe this. First of all, diode, in this case diode is in reverse bias, so it means it is in open circuit, there is no current flows through circuit, that's why we can apply the input, that input is goes to resistor, resistor can drop the some voltage, that is the input voltage, that is goes to output voltage. Therefore, if Vi is less than VR, output voltage is equal input voltage. So, and second case is nothing but if diode is in reverse bias, so diode is in forward bias, it conducts currents, so it is a short circuit, so therefore the voltage drop across the resistor, so that is output is equal to bias voltage. Okay, so next, in this case, during negative half cycle, in this case during negative half cycle of the input signal, the diode does not conduct and hence the output voltage is same as the input voltage, therefore V0 is equal Vi. So therefore, so output waveform in negative half cycle appears at the same waveform, okay, of input. Okay, this is nothing but biased shunt diode positive clipper, biased shunt diode positive clipper, biased series diode positive clipper and biased shunt diode positive clipper are also completed. Two types of biased positive clipper is completed. Okay, and next, biased negative clippers. Next topic is biased negative clippers. So these negative clippers are also divided in two categories: biased series diode negative clipper, biased shunt diode negative clipper. First of all, we discussed about biased series diode negative clipper. See this figure, this is the circuit of series diode biased negative clipper and also input and output waveforms. In this circuit, we can apply the positive half cycle of the input signal. During positive half cycle of the input signal, the diode, observe this waveform, observe this circuit also. So during positive half cycle of the input signal, the diode conducts and act as a short circuit. Diode conducts and act as a short circuit because diode is in forward bias. Cathode is connected to negative through resistor and anode is connected to positive. Okay, so here that's why diode is in forward bias, it conducts currents, it acts as a short circuit. So we can apply first of all positive half cycle at the input of circuit that goes to output. Okay, therefore the output voltage is same as the input voltage, therefore V0 is equal Vi, V0 is equal Vi. Okay, so at the same way, during negative half cycle of the input signal, during negative half cycle of the input signal, here negative half cycle means polarities are changed, that's why diode is in reverse bias because cathode is connected to positive and anode is connected to negative. Diode is in reverse bias. It does not conduct currents. So it is a open circuit. As long as, so the input Vi is less than or equal minus Vr. Minus Vr means it is a negative clipper. That's why minus Vr. Bias is the negative polarity. You can take first of all negative polarity. That's why minus Vr. The diode does not conduct as long as the input Vi is less than or equal minus Vr. So the output voltage is at minus Vr level. So the output voltage is at minus Vr level. Observe this negative half cycle. When the input voltage is Vi is greater than minus Vr, the diode conducts and hence output voltage is same as the input voltage. Okay. So the condition V0 is equal Vi if Vi is greater than minus Vr. Okay. So observe this output waveform of biased series diode negative clipper. Positive is forming as usual and negative half cycle. So up to Vr waveform forms up to Vr. So after Vr they clip off. Okay. So this is nothing but biased series diode negative clipper. And next one is biased shunt diode negative clippers. Biased shunt diode negative clippers. Okay. So this is the circuit and input and output waveforms of biased shunt diode negative clipper. So in this circuit, observe this circuit during positive half cycle of the input signal. During positive half cycle of the input signal, the diode does not conduct. During positive half cycle of the input signal, the diode does not conduct and act as an open circuit. The diode does not conduct and act as an open circuit. So the output voltage is same as the input voltage, that is V0 is equal Vi. That is V0 is equal Vi. I repeat once again. During positive half cycle of the input signal, so it acts as an open circuit. So output voltage is same as the input voltage, that is nothing but V0 is equal Vi. And next, during negative half cycle of the input signal, the diode conducts as long as the input voltage. Vi is less than minus Vr. So the output voltage is at minus Vr level. So next, when the input voltage Vi is greater than minus Vr, the diode does not conduct and it acts as an open circuit. So the output voltage is same as the input voltage. Okay. I repeat this negative half cycle once again. During negative half cycle of the input signal, the diode conducts as long as the input voltage. Vi is less than or equal minus Vr. So the output voltage is at minus Vr level. When the input voltage Vi is greater than minus Vr, the diode does not conduct and it acts as an open circuit. So output voltage is same as the input voltage. Okay. So next, if the conditions apply, if Vi is greater than minus Vr, then output is equal input. If Vi is less than minus Vr, then output voltage V0 is equal minus Vr. Okay. So observe this waveform, output waveform. So output waveform appears up to Vr, minus Vr. So after Vr they clip off. Okay. So this is nothing but biased negative clippers of series diode negative clippers and shunt diode negative clippers. Okay. All topics are completed. Okay, so biased positive clipper 2 types and also biased negative clippers 2 types are also completed. Okay, and next summary of this presentation, we have seen biased series diode positive clipper, biased shunt diode positive clipper, biased series diode negative clipper, biased shunt diode negative clipper. So these topics are completed. Okay, and next frequently asked questions may be asked. The first question is, explain the operation of biased positive clippers with the help of circuit diagram and waveforms. With the help of circuit diagram and waveforms. Okay, so in this topic, so different type of questions may also be asked. So first question is, draw the circuit and input and output waveforms of biased positive clippers. Okay, so you can write in this question, so both series diode and also shunt diode. Okay, if it mentioned or not. Okay, so another question may be asked, explain the operation of biased series diode positive clippers with the help of circuit diagram and waveforms. Or another question may also be asked in this topic also, explain the operation of biased shunt diode positive clippers with the help of circuit diagram and waveforms. Okay, and other question may also be asked, explain the operation of biased negative clippers with the help of circuit diagram and waveforms. This question may also be asked, explain the operation of biased series diode negative clippers with the help of circuit diagram and waveforms. Or another question may also be asked, explain the biased shunt diode negative clippers with the help of circuit diagram and waveforms. And another question may also be asked, draw the circuit diagrams and input and output waveforms of negative clippers. Okay, so or different ways of questions may also be asked in this topic. Draw the circuit diagram and input and output waveforms of biased series diode negative clippers. Or another question, draw the circuit diagram and input and output waveforms of biased shunt diode negative clippers. Okay, so different type of questions may be asked in today topic. Okay, so today topics are very important topics. Today topics are very important topics in short questions and also essay type questions. Okay, today topics are very important topics, don't confuse them. Okay, any doubts? Okay, thank you.